Fine. Let's take another example of Lagrange's method. The last example which we had taken was a simple one to understand just the method. Okay. We'll increase the difficulty level of the question. The question again remains solve the partial differential equation. The equation being this time y square z over x multiplied by p plus x times z into q is equal to y square. So this is a question. Let's begin with the solution. To begin with the solution, we start with the auxiliary equation, which is going to be dx over p. So p in this case is y square z upon x, the x goes in the numerator, dy divided by q, which is x times z, and dz divided by y square. Okay. Once we get this, we are supposed to make pairs of two of them and solve it. You can choose any two combination. Suppose I choose the first and the last one because I see y square common there. So suppose I take this and this. So y square gets cancelled. I'll be left with x dx is equal to z dz. And we'll have x square upon 2 is equal to z square upon 2 plus say c1, where c1 is a constant. So I'll have x square minus z square is equal to 2c1, or I can call this as c2. This is one of the independent solutions which we have found. Now we have two other options. You can take first and second, or second and third. If I take first and second, z will get cancelled. What happens if I take second and third? Will I be able to integrate it? Will I be able to separate the variables? You will always have a independent variable and dependent variable coming together. You have three variables, x, y, and z, which becomes difficult to solve. So second and third combination is not possible. We'll have to definitely work on the first and the third. So I'm taking the first one, which is x dx upon y square z. The z gets cancelled. And we're left with y square dy is equal to x square dx on cross multiplying. On integrating, I'll get y cube upon 3 is equal to x cube upon 3 plus I can say c3. Multiplying throughout by 3, I'll get y cube is equal to x cube plus 3 times c3, or I can call this as c4. That is equal to here, or let me put a minus here and equal to here. So we have found two solutions here. The general solution is written as x square minus z square and y square minus, y cube minus x cube is equal to 0. This is your general solution. I hope no doubts on this question. Is this clear? Yes, please. Is this clear?
Yes, ma'am.
Okay. Moving on to little different types of questions. Okay. These are the basics which we have taken. Okay. Sum number 3. Again, we are expected to solve the PDE. We have y squared p minus xy times q is equal to x times z minus 2y. Let's try and simplify them. Okay. Again, come on. Can anyone tell me the auxiliary equation? Step number 1 is to get the auxiliary equation. What will you get here? Yes. What will be the auxiliary equation here? Come on. What will be the auxiliary equation? Yes, Ishika, Pratibha, Sarfara, Swati.
Yes, ma'am.
What's the auxiliary equation here? आपको आंसर आना चाहिए. ऑक्सिलरी इक्वेशन बनाना नहीं आ रहा है आप लोगों को? यस स्वाति.
It's dx upon y square is equal to dy upon minus xy is equal to dz upon x in bracket z minus 2y.
वेरी गुड. इतना सिंपल सा क्वेश्चन था. करेक्ट. सो dx अपॉन वाई स्क्वायर इज इक्वल टू dy अपॉन नेगेटिव xy इज इक्वल टू dz अपॉन xz minus 2yz. आई एम ओपनिंग द ब्रैकेट. इज इज ओके? फाइन. इसके बाद क्या करना है हमको? कौन से दो इक्वेशंस को साथ में ले सकते हैं? दो इंडिपेंडेंट सोल्यूशन बनाने हैं हमको. इक्वेशंस को कैसे साथ में लेंगे? कम ऑन. मैंने दो सम्स ऑलरेडी कर लिए हैं इस टाइप के. थर्ड सम पे मूव हो रहे हैं. तभी आंसर्स आपसे चाहिए मुझे.
Okay, ma'am.
बताइए.
We can take first two equations.
Okay, only Swati is answering, right? So dx upon y square is equal to negative dy upon xy. एक एक y cancel हो जाएगा. We'll have x dx is equal to negative y dy. चलो इसका सॉल्विंग कंप्लीट करके मुझे बताओ आपको क्या मिल रहा है आंसर से.
X square plus y square uh, is equal to C1.
Very good. X square plus y square is equal to c1. Okay, you can use any alphabet here. No problem. Very good. चलो अब इसके बाद कौन सा लेंगे इक्वेशन? इसके बाद कौन से इक्वेशन के हमारे पास ऑप्शन है?
We can take first and third or second and third.
Okay, so if I take second and third, or if I take first and third, फर्स्ट एंड थर्ड में कुछ भी कॉमन नहीं है. करेक्ट ना?
Yes, so we can take second and third.
वी कैन टेक सेकेंड एंड थर्ड. ओके. आई थिंक यहाँ पे थर्ड में एक्स था, राइट? एक्स कॉमन था. ओके. सो
Yeah,
लेट्स
X is
ट्राई
common.
सेकेंड एंड थर्ड. सो डी वाई अपॉन नेगेटिव एक्स वाई इज इक्वल टू डी जेड. एक्स कॉमन ही रखते हैं. जेड माइनस 2y. So x gets cancelled. I'm left with negative dy by y. But here again I have a y remaining. Variable separable form में यहाँ पे सिर्फ z बचना चाहिए था. Correct? So let's see. Let's cross multiply. If I cross multiply, I have 2y positive with dy. Z will become negative with dy. And here y dz. Is this correct? Any doubts? Clear so far?
Yes, ma'am.
Now I leave this as 2y dy, and here I write this as y dz plus z dy. Okay, I have just shifted the z dy on the other side. Now let's observe these two terms. These two terms. Is this the same as the derivative of yz? If you apply UV rule, adding the derivative of yz, you would get y dz and z dy. Is that correct?
Yes, ma'am.
Okay. So now what we're going to do is we would now integrate both the sides. We get 2 times integral y dy and here integral of dyz. The left hand side becomes y square, 2 gets cancelled. Right hand side to integral and derivative cancel each other. We'll be left with yz and there'll be a c2. So we now have y square minus yz is equal to c2. Is this understood? Is the method clear?
Yes, ma'am.
What about the other people?
Yes, ma'am.
Okay, good, fine. So now we've got two solutions. दो solution मिलने के बाद हमको सिर्फ final solution लिखना होता है. But the general solution is f of x square plus y square comma y square minus yz equal to 0. ठीक है? तो ये आपको third sum complete हो गया. Now we are moving to the actual multiplier method. What we have done is also multiplier method, but I'll explain it a little later. Exactly इसमें और उसमें difference क्या है? Once you see the fourth sum, you'll understand the difference here. ठीक है? So let's look at the next question. Again, the question will be to solve the PD or solve the equation x times p minus y times q is equal to y square minus x square. We're expected to solve this particular partial differential equation. So let's begin again with the auxiliary equation. Dx upon x, dy upon negative y, and dz upon y square minus x square. ठीक है? This is your auxiliary equation. इसके बाद क्या करेंगे हम? कौन से दो को लोगे तो सॉल्व हो सकता है? फर्स्ट
First
एंड
two.
सेकंड. यस,
First
फर्स्ट
or
एंड
second?
करेक्ट. फर्स्ट एंड सेकंड को सॉल्व करेंगे तो क्या मिलेगा आपको? If you integrate both the sides, first integral is log x. This is negative log y. And generally we write the constant as log c1. This becomes log x plus log y. And यहाँ पे हो जाएगा log of c1. This is log of xy is log of c1. And you take xy is equal to c1, equation number 1. What about the next combination? First second करके आपको ये आंसर मिल चुका है. What about the next combination? Will you use second third या फिर first third? Yes, please. क्या कॉम्बिनेशन यूज करने के हमको आंसर मिलेगा? Is it possible to try second third? Second third वर्कआउट होगा कि नहीं होगा?
Maybe second, third, ma'am.
सेकेंड थर्ड में आप क्रॉस मल्टीप्लाई कर लो, चेक करो. सेकेंड एंड थर्ड. ओके, पहली बात तो वहां पे z नहीं है. तो इट्स नॉट गोना वर्कआउट, राइट? आपके वेरिएबल सेपरेट होने चाहिए थे या फिर जो कंबाइन होते जैसे प्रीवियस सम में x dy y dx ऐसा हुआ था ना वहां पे. यहाँ पे ऐसा भी नहीं हो रहा है. तो सेकेंड थर्ड इज नॉट गोना गिव यू एनी सोल्यूशन. First third is no different. It is also not going to give you any solution. Okay. So now let's understand This is where we introduce the Lagrange's multiplier method. We introduce the Lagrange's multiplier method. Understand the method carefully and things will be easy. Okay. Now what does Lagrange's multiplier method do is, along with dx divided by p, dy divided by q, and dz divided by r, we introduce some number or constant or function times dx, another function times dy, n times dz divided by L times P, M times Q, and N times R. What have we done? फर्स्ट रेशियो को ऊपर नीचे L से मल्टीप्लाई कर दिया, सेकेंड रेशियो को M से एंड थर्ड रेशियो को N से. ये L, M, N आपके कोई भी फंक्शंस या नंबर्स हो सकते हैं एंड उनका एडिशन कर दिया है. दिस इज योर थ्योरम ऑन इक्वल रेशियोज. So when you do that addition, your answer will always be equal to the previous ratio. Always. Okay, you can check with your examples. Like if I give you an example here, say if I had 2 by 3, 4 by 6, say 20 by 30, all of these ratios are equal, right? I just add them, just directly add them. So if I add them, I'm getting 26 divided by 39. And if I cancel out, it is 13 twos are 13 threes are. Back to the original ratio. So that is why we can write this equal to, okay? So addition, multiplication of ratios is allowed, subtraction is allowed. This is theorem on equal ratios. Okay. So Lagrange's multiplier method में you will introduce a fourth ratio. You will bring in purposely जब आपके दो कॉम्बिनेशन से आपको दो आंसर नहीं मिल रहे हैं, जैसे इस केस में मुझे एक आंसर मिल गया, मैं दूसरा आंसर नहीं मिला अब तक, then in that case you will introduce a fourth ratio and it is desired, or you will introduce a fourth ratio in such a manner that the denominator becomes 0. फोर्थ रेशियो ऐसा लाना है कि आपका जो डिनोमिनेटर हो वो 0 बन जाए. ठीक है. सो नाउ ऑब्जर्व योर थ्री रेशियोज. तीनों के डिनोमिनेटर्स को ऑब्जर्व करो. ऐसे कौन से नंबर से मल्टीप्लाई करके ऐड करोगे कि आपका फाइनल आंसर आपको डिनोमिनेटर में 0 मिलना चाहिए. यस प्लीज ऑब्जर्व द थ्री रेशियोज व्हिच यू हैव विथ योरसेल्फ. It's a game of observation. It's how you are able to tackle it. What will happen if I multiply the first ratio with x over x? Of course, if I'm multiplying in the denominator with x, numerator में भी x से multiply हो जाएगा. Here with y, and then I add the two ratios. No changes in the third. What will happen if I do this? Will I get a denominator 0? Will I be able
Yes,
to get
ma'am.
that? Okay. So this x and y, they are called Lagrange's multiplier. Okay. So now because I'm using the Lagrange's multiplier method exclusively, so I'll write by Lagrange's multiplier method. This entire ratio dx over x, dy over negative y, and dz over y square minus x square is equal to the fourth ratio, which is x times dx, y times dy, plus 1 times dz. dz ko we have not multiplied by anything, so 1 time. Denominator now becomes 0. Okay? And therefore now I can say x dx plus y dy plus dz is equal to 0. On cross multiply with any of the ratios, you will get the answer as 0. Now we integrate them. So I'll get integral of x dx plus integral of y dy plus integral of 1 dz is equal to 0. or integral of 0, you can say. So this is x square upon 2, y square upon 2 plus z as it is equal to c2. We'll multiply throughout by 2 and we'll get x square plus y square plus 2z is equal to c3, where c3 is equal to 2 times c2. Did you all understand what did we do here? Is the method understood and clear with everyone? Did you get this? Yes, please. Let's understand. The Lagrange's multiplier method will be used whenever आपको दो independent solution नहीं मिल रहे. You're able to find only one or you're able to not find even a single one. Okay, we'll take example of questions जहाँ पे एक भी नहीं मिलेगा. इस question में आपको एक आंसर मिल गया था. We were not able to find the second one. So in that case, you multiply the terms with some functions or constants. Generally, Lagrange's multipliers are, okay, I'll make a list here. The common multipliers are we have either they're taken as 1, 1, 1, or you can have minus 1, minus 1, minus 1, or you can have a combination. Okay. Two of them are 1, one is minus 1, two are minus 1, one is 1. Whichever way. Combination of 1s and minus 1. You could have x, y, z. You could have,
Ma'am,
yes, please.
by Lagrange's multiplier method, after that, this plus y dy is minus y dy. Is it?
Sorry, I did not get you.
After this step of Lagrange's multiplier method,
You're talking about the denominator minus?
no, if there is denominator is 0, numerator
No, no,
is
no, no.
x dy plus y dy or minus y dy.
1 minute. You are talking about this negative sign here?
No, is equal to here, right hand side.
You're talking about this one, right?
Yes.
That will be plus itself, no? I'm multiplying by plus y. If I multiply by plus y, then this negative y square and the positive y square of the third term will go away, no? There is a y
Yeah,
square.
yeah, I get it. I
Okay.
get it.
Okay. I hope the
Okay,
problem is
thank
clear.
you.
Yeah.
Yeah.
So now we were talking about the common multipliers. So the common multipliers could be positive 1, negative 1, x, y, z. You could have x square, y square, z square. You could have 1 over x, 1 over y, 1 over z. Now it doesn't mean they will always be in this combination. The combinations could change. Now let's understand. When I started with this sum, I told you previous sums were also Lagrange's multiplier. वहां पे हमने multiplication में 1 1 1 ही use किया है. हमने fourth ratio introduce नहीं किया, जरूरत नहीं पड़ी. Okay? But now this sum onwards we were required to have the fourth ratio present there. I hope this is very much clear with everyone. How did we find the solution is okay? Yes, students. We'll of course look at few more examples. But is this method okay? Students, your reactions can help me understand. Okay, thank you. What about the other people? Stefanas has understood. Okay. We now note down the general solution. So the general solution will be f of xy, comma x square plus y square plus 2z is equal to 0. Okay, so that's your general solution to this particular question. Let's understand the method better with the help of one more example. So this will be sum number 5. We have y plus z times p minus z plus x times q is equal to x minus y. Let's begin with the auxiliary equation, and the question is again to solve the PDE, okay? So the auxiliary equation is dx over y plus z, dy over negative xz plus x, and dz over x minus y. Tell me which two values you can take to solve it and get two independent solutions here. Can you directly get two independent solutions here? If I take first, second, second, third, or first, third. No, we are not going to get any of the solutions, right? So we introduce Lagrange's multiplier method. So by Lagrange's multiplier method, you'll have to write full form in the exam. Let me take L, M and N is equal to 1 each. Remember, आपका aim है third ratio का जो denominator है, that should come out to be 0. The third ratio or the fourth ratio which you're going to introduce, the denominator should come out to be 0. Okay? So let's get the fourth ratio 0. Let's understand if I put 1, 1, 1 each, I'll get dx over y plus z, dy over negative z, negative x, and dz over x minus y. Because I've put in 1, 1, 1, I'll have dx plus dy plus dz, and denominators will get added. So if you look at the denominator, what we are getting is a 0. Check the addition. Is it coming to 0? Is the denominator coming to 0? Yes, please. Are you guys able to see that? Okay. Once the denominator becomes 0, you take it as equal to any ratio, or you directly write dx plus dy plus dz is equal to 0. Integrating, I'll get x plus y plus z is equal to c1. Is equal to c1. I got one independent solution. I got one independent solution. I require one more independent solution. Okay. Now, how do you get one more independent solution? Again, apply Lagrange's multiplier method. This time, let's try L is x, M is say y, and N is say z. Okay, if that is the case, give y plus z, negative z, negative x, x minus y. L times dx, M times dy, N times dz. Denominator में x times y, x times z, negative yz, negative xy. Correct? And z times x, z times y. 0 नहीं बन रहा है. Let me take this as negative z. So if I take negative z, check, is it becoming 0 now? So my n should be negative z. Is that fine? Now, was it compulsory कि आपका n ही negative हो? What if I would have taken y? No, y में नहीं work करता. n की value ही negative करनी पड़ती. So you could have मैनेज दिस, या फिर आपको x एंड y मतलब l and m की वैल्यूज नेगेटिव लो एंड n की वैल्यू पॉजिटिव लो, दैट कॉम्बिनेशन विल आल्सो वर्क. इज दैट फाइन? एनी डाउट सो फार? Did you understand how we are managing the multipliers? And let's understand, जितना practice करोगे आपको multipliers easily मिलते जाएंगे. You will be able to find the multipliers. Okay? So once we've got these multipliers, I have x dx, y dy, and z dz is 0. Let's integrate. I'll have x square upon 2, y square upon 2, and z square upon 2. C2 multiply throughout by 2. You'll have x square plus y square minus z square is equal to C3. Equation number 2. And now you have your general solution, which is f of x plus y plus z, and x square plus y square minus z square equals to 0. Any doubts? Is the sum clear with all of you?
Yes, ma'am.
Okay. So these were two methods by which we solve the auxiliary equation. Before we learn the next two methods, we'll do little more on these two methods. That is, we will be solving the Cauchy problem using the Lagrange's multiplier method. Okay. So if you look at your syllabus, there is no mention of Lagrange's multiplier method. What is mentioned is the Cauchy problem and finding the general solution or the solution of the Cauchy problem. When they say finding general solution, you will find Lagrange's multiplier method. You will apply Lagrange's multiplier method and find the solution, or the CAL method of statistics. Okay, and find the answer. But when we talk about Cauchy's problem, let's understand what are we looking at over there. Okay, that's also a sum which is based on Lagrange's multiplier method. We will do more types on Lagrange's in the next lecture, but today, because we've learned these two types, we're going to do sums which are based on this. Okay. Now, what is this Cauchy's problem? Before you understand the Cauchy problem, let's understand what are we doing here. When you solve a particular PDE, solving a PDE is actually equivalent to finding an integral surface. Correct? Because we are working in 3 dimensions. We are working in x, y, and z. We are working as z as a function of x comma y. Z which was dependent on x and y. And when you solve this PDE, you will get that function, which will be a 3-dimensional thing. Okay? So you're working in 3 dimensions here. Okay. Getting back here. So what we get is a solution as an integral surface. Okay. Now when we talk about a Cauchy problem, there will be an initial value. You remember initial value problems of ordinary differential equation? So there will be an initial value curve given to you. Here there will be curves or Yeah, the curves will be given to you. Now, when these curves are given, we look at the integral surface जिसके अंदर ये curve lie करेगा. That will be the answer for the Cauchy problem. So when we talk about Cauchy problem, what you are trying to do over here is you're trying to search an answer to the initial value problem. That's what we are doing here. Okay, I hope this is understood. So if we look at the partial differential equation parallel to ordinary differential equation, the Cauchy problem is equivalent to solving the initial value problem. Okay, so there'll be a Cauchy data. The initial data is called the Cauchy data, which will be given to you. And you're expected to use this Cauchy data, and to find that integral curve, there'll be an integral curve, okay, or integral surface in which the curve which is given, this is a Cauchy data. This will be the Cauchy data. So there'll be this curve which is lying on that integral surface. तो आपको एक integral surface ढूंढना है जिसके अंदर ये curve है. So basically PDE का जो answer आता है, whatever you got the answers, you know, these answers, x plus y plus z equal to some number. So what is this x plus y plus z? If I'm looking at three-dimensional, x plus y plus z will become these surfaces, planes. जैसे जैसे आप c की value x plus y plus z was equal to c1, no? Correct? So if I look at x plus y plus z over here is equal to, say, suppose 1. What will happen? What will be the points through which it will pass? It will pass through 0, 0, 1, 0, 1, 0, and 1, 0, 0, correct? So if I look at this, suppose this is 1, 1, and 1 here. So this is our plane. The minute I change the number, say if I put x plus y plus z is equal to, say, 3, what will happen? It will pass through 3, 3, 3. Correct here? Are you understanding this? Do you get this? Of course, the diagram is in 2 dimension, but these are planes. These are planes. So there is this one plane. Uske upar this is another parallel plane. So these are parallel planes. We are searching for that plane जिसके ऊपर हमारा जो required curve है वो lie करेगा. Okay? So suppose the given condition is x plus y is equal to 3. So my integral planes which I was getting were x plus y plus z is equal to some constant. All those parallel planes, right? If I'm drawing in 2-dimensional figure, all those parallel planes are here. We were looking at the one on which x plus y is equal to 3 will lie. So that will be that line where x plus y plus z is equal to 3. That plane will have this particular line. I hope this is understood by all. So this is what we do when we solve a Cauchy problem. So in Cauchy problem, technically there is an initial condition given to you. So what you will do is first find the general solution using the Lagrange's multiplier method, which we have just recently learned. And in that multiplier method, you will substitute the initial conditions to find the particular answer or to find the integral surface on which the initial curve lies. I hope this is understood by everyone. Is this clear?
Yes, ma'am.
Okay. Let's understand this with the help of an example. The question goes like this. Find solution of the first order PDE u times x plus y multiplied by ux plus u times x minus y multiplied by uy is equal to x square plus y square. With u equals to 0 on y is equal to 2x. So let's understand here. This is your PDE and this is your Cauchy data, or your initial data given to you in the question. Over here, this ux is nothing but your small p. Your uy is nothing but your small q. Understand the question is working on the alphabet u instead of alphabet z. Previous questions में हम alphabet z पे काम कर रहे थे, इस बार हम alphabet u पे काम कर रहे हैं. Okay? So I hope there is nothing confusing. ऑक्सिलरी इक्वेशन में dx डिवाइड बाय कैपिटल P यहाँ से मिलेगा, so u times x plus y, dy डिवाइड बाय capital Q, so capital Q over here would be u times x minus y, and du this time, not dz, divided by x square plus y square. Okay, this is your required auxiliary equation. Now, once you got the auxiliary equation, tell me which two equations to equate to get your answers. Can we equate the first and second? All your steps of Lagrange's will follow here, okay? All your steps of Lagrange's will follow. Come on. How do you begin? Will first two equations work? What if I took this? Can I cancel out u here? एक बार u cancel कर दिया, cross multiply करोगे तो x dx, y dx, x dy, y dy. Is this correct? There is no problem with this term, there is no problem with this term. The problem is only and only with these two terms, because y के साथ dx and x के साथ dy है. And if you remember, two sums before we have done something similar. So x dx as it is, negative y dy, I brought this y dy here, this side, shifted the yellow term this side, and x dy, y dx. The left hand side I can integrate directly, because x के साथ dx है, y के साथ dy है. Right hand side क्या कर सकते हो आप? What
It
can
is
you
the
do?
derivative of xy.
Very good. It's a derivative of xy. Okay, so you need to understand to identify the patterns. If it's a derivative of xy, I would integrate both sides. Integrating both sides will give me x square here, y square here, of course, upon 2. And यहाँ पे integrate करके xy plus a constant c1 multiplied throughout by 2, we will get x square minus y square minus 2xy is equal to c2. Is equal to c2. Any doubts? Is this clear? Okay.
Yes, ma'am.
Now we got the answer to one, or we got one independent solution. Will it be possible to get another independent solution by comparing first and third or second and third? वहाँ पे तीन अल्फाबेट्स आ रहे हैं, U, X and Y. Cancel out कुछ भी नहीं हो रहा है, right? So, of course, we'll have to go for Lagrange's multiplier so that denominator का addition 0 हो जाए. ऐसे किस term से multiply करोगे तीनों को so that your denominator becomes 0? Come on.
First by x minus y, second by x plus y, and third by u.
अगर first को x minus y से multiply किया, as you're suggesting, correct ना?
Yeah.
Okay, let's check. First by x minus y, second with x plus y, and third with u. Let's check what will we get. We'll get u times x square minus y square, correct? U times x square minus y square, and u times x square plus y square. So u plus y square and minus y square, one of the terms will get cancelled. But 0 नहीं बन रहा है.
Yes.
तो ये try गलत. Good, you tried, but then this try is not correct. Chalo, which other numbers can we try? Of course, this is all about trial and error and little observation. That's it. And with little more practice, observations would be faster. First term multiplied by
Now, first term x plus y plus divided by
X plus Y.
Second term,
Okay.
we add x plus y plus
Sarfaraz, can you repeat please? First वाला किससे?
x plus y.
Okay. अच्छा अब लोग
Now,
अच्छा लिसन अब लोग ना थोड़ी चीजें कॉम्प्लिकेट करो। मैंने ना लिस्ट ऑफ कॉमन मल्टीप्लायर्स दिए थे, देखा आपने? क्या हम यही वाले ज्यादातर यूज करते हैं कॉमन मल्टीप्लायर्स? जैसे +1 +1 +1 या -1 मतलब 1 - 1 एक्स वाई जेड एक्स स्क्वायर वाई स्क्वायर जेड स्क्वायर 1/x 1/y 1/z, ये कॉम्बिनेशन यूज करते हैं मैक्सिमम। तो ये वाले कॉम्बिनेशन में से कुछ ट्राई करें, कॉम्प्लिकेटेड करने से बेटर।
yes ma'am.
चलो इसमें से कुछ ट्राई करो अभी। पॉजिटिव नेगेटिव का कॉम्बिनेशन अलाउड है। तो यहाँ पे थोड़ा सिंपल करते हैं, x प्लस वाई नहीं लेते, सिंपल सा लेते हैं। चलो सिर्फ x लिया तो यहाँ पे सिर्फ x, यहाँ पे सिर्फ y और यहाँ पे सिर्फ u, क्योंकि z नहीं है उसकी जगह u है हमारे पास, राइट? तो यहाँ पे x, यहाँ पे y, यहाँ पे u, तो क्या मिलेगा आपको? फर्स्ट टर्म u टाइम्स एक्स स्क्वायर प्लस एक्स वाई हो जाएगा, राइट? और तीनों में u है तो मैं u बाहर ही रखती हूँ। सेकेंड में आपको मिलेगा एक्स वाई माइनस वाई स्क्वायर। थर्ड में आपको मिलेगा एक्स स्क्वायर प्लस वाई स्क्वायर, करेक्ट? तो यहाँ वाई स्क्वायर तो कैंसिल हुआ, बट बाकी के टर्म्स कैंसिल नहीं हो रहे हैं। बट ये जो टर्म्स है वो सारे के सारे सेम टर्म्स प्रेजेंट है। व्हाट इफ वी चेंज द साइन? व्हाट इफ वी चेंज द साइन? टर्म्स तो सेम है ना? व्हाट इफ आई मल्टीप्लाई हियर बाय नेगेटिव यू? अगर ये नेगेटिव यू हो गया तो ये नेगेटिव एक्स स्क्वायर हो जाएगा और ये
x
नेगेटिव
minus
वाई।
ma'am.
हाँ बट
दो
अगेन ये कैंसिल हुआ, ये कैंसिल नहीं हुए, तो व्हाट अबाउट माइनस वाई? अगर माइनस वाई हो गया तो ये नेगेटिव हो जाएगा, ये पॉजिटिव, राइट? देख लो, जीरो बन रहा है। अगर मैंने x को पॉजिटिव रखा और y एंड u को नेगेटिव रखा तो क्या ये जीरो बन रहा है? या फिर आप सिर्फ फर्स्ट वाले x को नेगेटिव कर दो और बाकी दोनों को पॉजिटिव रख दो, y एंड u को, तब भी आपका जीरो बन जाएगा। इज दैट करेक्ट?
yes ma'am.
ओके, सो यू कैन टेक एनी ऑफ द टू कॉम्बिनेशंस। और भी कोई कॉम्बिनेशन होगा तो चेक कर सकते हो आप, ऑफ कोर्स, बट ये दो यहाँ पे वर्क कर रहे हैं। चलो यहाँ पे we'll apply Lagrange's multiplier method. And what we get here is dx upon u times x plus y, dy upon u times x minus y, and du upon x square plus y square is equal to x times dx minus y times dy minus u times du divided by 0. Division by 0 allows us to cross multiply, and what we get is x dx, y dy, u du is equal to 0. Integrating, we'll get x square by 2, y square by 2, u square by 2 is 0. No, sorry, not 0, constant. C3 I'll use now. Multiplying throughout by 2, I'll get x square minus y square minus u square is C4. And finally, you can write this as function of x square minus y square minus 2xy, x square minus y square minus u square is equal to 0. This what we have got is a general solution. ठीक है, ये हमको जो मिला है वो जनरल सोल्यूशन है, सम कंप्लीट नहीं हुआ है बिकॉज यहाँ पे कॉशी डेटा गिवन है, उस कॉशी डेटा को यूज करके आपको सम को सॉल्व करना है। तो लेट्स सी इसके आगे क्या करना है। यहाँ तक हमने जो किया है वो सारा का सारा हमने Lagrange's multiplier method अप्लाई किया है, which we have learned before this. Okay, and we have done multiple sums on this. So I hope there is no doubts till here. Okay. Now let's look at the Cauchy data. What is the Cauchy data given? U is equal to 0 and y is equal to 2x. U is equal to 0 and y is equal to 2x. We'll substitute this Cauchy data in equation number 1 and equation number 2. We substitute U is equal to 0 and y is equal to 2x in equation number 1 and 2. Okay. And you will now try to remove the C1, C3, C2 and C3. जितने आर्बिट्री कॉन्स्टेंट्स है उनको आपको हटाना है इक्वेशन से, तब आपको पर्टिकुलर सोल्यूशन मिलता है. तो फर्स्ट इक्वेशन में अगर डालेंगे x square as it is, y square will become 2x का square which will become 4x square, 2 times x as it is, यहाँ पे again multiplied by 2x is c2. इसी को पहले कंप्लीट करते हैं, negative 3x square, negative 4x square is c2. So you get negative 7x square is c2, or you have x square is equal to negative c2 upon 7. Same way equation number 2 में अगर डालेंगे values, or let me not call this as equation 2, इसको equation 2 बुलाते हैं. x square as it is, यहाँ पे 4x square हो जाएगा, u की जगह 0 है, so आपको negative 3x square is equal to c4 मिल रहा है, या फिर x square is equal to negative c4 upon 3. Equation number 3 and 4 both are x square, so both the values will be equal. So now I can say from 3 and 4, c2 upon 7 is equal to c4 upon 3. I've just removed the negative sign from both sides. So I can say 3 times c2 is equal to 7 times c4. यहाँ पे equation number 1 and 2 की values डालेंगे. Equation number 1 से ये equation मिला, right? This equation is from equation number 1. So 3 times x square minus y square minus 2xy. 7 times c4 equation 2 से आएगा. I can see this equation does not have any arbitrary constant. So you have solved the Cauchy problem. आपको वो कर्व मिल गया है जिसके ऊपर आपका जो गिवन डेटा है, द Cauchy डेटा है, वो लाई कर रहा है. सिर्फ इसको थोड़ा सा सिंप्लीफाई करेंगे बिकॉज दोनों साइड x square y square and u के टर्म्स है. We'll just bring them all together. So now I have 3x square minus 3y square minus 6xy is 7x square minus 7y square minus 7u square. So I can write this as 7u square is equal to 7x square minus 3x square minus 7y square plus 3y square and plus 6x square. This turns out to be 4x square, 4y square and 6x square, which is equal to 7u square. This is your solution to the Cauchy problem. I hope the sum is clear. Did you guys understand this? So what we have done so far is we learned how to solve a PDE using Lagrange's multiplier method. We have learned only 2 methods there. उन दोनों methods के basis पे we learned how to solve the Cauchy problem. Okay? So if you know how to handle the Lagrange's multiplier method, Cauchy problem ज़्यादा कुछ नहीं है, थोड़ा सा आगे you just have to substitute the initial value problems and combine it together. I hope these examples are clear. Next lecture, we will learn more of Lagrange's multiplier method and few more examples of Cauchy problem. And then first half of unit 1 will be completed. The Cauchy and semi-linear types of PDE, we have completed the methods of solving them. I hope this is clear with everyone. Okay, so one more lecture I'll require to complete the first half of unit number 1 and 2 more lectures to complete the second half. Then we'll be done with unit 1 and you will have your internals on unit number 1. So we'll stop for today here. I hope no one has any doubt. Yes, please. Is this clear? Okay, fine. So we'll end the lecture here. Thank you, students.